Mars, the red planet. A world of mystery, potential, and ambition. For centuries, humans have gazed at this desolate neighbor with wonder. Today, Mars is more than just an object of fascination. It's a frontier that could one day become humanity's second home. But the big question remains: how could we transform this barren desert into a thriving, Earth-like world? Let's explore the fascinating, complex, and often controversial plans to terraform Mars. Why terraform Mars? Why are we so focused on Mars? The answer lies in its potential. Mars is the most Earth-like planet in our solar system. While Venus is closer in size and composition, its 900-degree F surface and crushing atmosphere make it virtually impossible to colonize. Mars, on the other hand, has polar ice caps, seasons, and a day length similar to Earth's. It's challenging, but not beyond the realm of possibility. Another reason is survival. Earth faces mounting challenges: climate change, overpopulation, and the risk of global catastrophes. To ensure humanity's survival, we need a backup plan, a place to expand and thrive beyond Earth. Terraforming Mars isn't just science fiction. It could be a key to our species' future. Understanding Mars' environment. Before we terraform Mars, we need to understand its unique environment. Mars is about half the size of Earth, with 1/3 of our planet's gravity. Its thin atmosphere, composed of 95% carbon dioxide, offers little protection from the sun's radiation. Temperatures average a freezing 80-degree F, 62 degrees Celsius, but they can plummet to 195-degree F, 125 degrees Celsius, near the poles. The surface is a cold, dusty desert, battered by planet-wide dust storms that can last for months. Liquid water can't exist for long here due to low atmospheric pressure, and there's no breathable oxygen. It's clear, if humans want to live here, Mars needs a complete makeover. The vision for terraforming. Terraforming Mars involves three main objectives: thickening the atmosphere, increasing the temperature, and creating water sources. These steps are critical for supporting life as we know it. Let's explore how scientists and visionaries propose to achieve each of these goals. Method 1. Thickening the atmosphere. Humans can't survive on Mars' thin atmosphere. It's just 1% as dense as Earth's. To make the planet habitable, we need to thicken the atmosphere. One popular idea involves releasing carbon dioxide trapped in Mars' polar ice caps and soil. This could create a greenhouse effect, trapping heat and warming the planet. Scientists have proposed deploying massive orbital mirrors to focus sunlight on the ice caps, causing them to sublimate and release CO2. Another idea involves bombarding Mars with nuclear explosions or asteroid impacts to release buried gases. But these methods are controversial, and recent studies suggest Mars may not have enough CO2 to sustain a thick atmosphere. So, what are the alternatives? Method 2. Warming the planet. Heating Mars is another critical step. Beyond melting polar ice caps, warming the planet would allow water to flow and create a more Earth-like climate. In addition to orbital mirrors, some have suggested using factories to pump greenhouse gases, like methane or sulfur hexafluoride, into the atmosphere. Other radical ideas involve crashing asteroids into Mars. These impacts would generate enormous heat and release trapped water and gases. While this method is theoretically effective, it would take decades to execute and could be catastrophic if poorly controlled. Method 3. Magnetic shielding. Mars' lack of a magnetic field is a major problem. Without one, the planet's atmosphere is constantly stripped away by solar winds. Researchers at NASA have proposed placing a large magnetic shield at the Mars-Sun Lagrange point, a stable position in space. This shield would deflect solar winds, allowing Mars to retain its atmosphere over time. Bringing water to Mars. Water is essential for life, and Mars has it, but in frozen form. Melting polar ice caps ice on approach, but there's also evidence of vast underground ice deposits. Mining these reserves could provide liquid water for human settlements. Another concept involves creating artificial lakes and rivers by redirecting melted ice. Over time, these water sources could support ecosystems, agriculture, and human populations, creating an ecosystem. Once water and a thicker atmosphere are established, the next step is introducing life. Algae, lichens, and other extremophiles could be planted to generate oxygen and organic material. These organisms are resilient enough to survive Mars' harsh conditions and could pave the way for more complex ecosystems. Over centuries, vegetation could spread, transforming Mars into a planet teeming with life. Imagine forests, rivers, and fields stretching across what was once a desolate red desert. The challenges of terraforming. While the vision of terraforming Mars is inspiring, it's fraught with challenges. First, there's the timeline. Terraforming is not a quick process. It could take hundreds, even thousands of years. Second, the costs are astronomical. Building the technology, launching missions, and sustaining operations on Mars would require trillions of dollars. Then there are ethical concerns. If microbial life exists on Mars, do we have the right to transform the planet, potentially destroying native ecosystems? And should we focus on fixing Earth before altering another world? What's next for Mars? While full-scale terraforming might be centuries away, the first steps could happen within our lifetime. Space agencies like NASA and private companies like SpaceX are already working on sending humans to Mars. These early missions will focus on building sustainable habitats and testing technologies for future terraforming efforts. Autonomous robots could begin preparing Mars for human colonization, extracting resources and testing small-scale terraforming techniques. Over time, these efforts could evolve into the grand vision of a second Earth. The dream of Mars. Terraforming Mars is one of humanity's most ambitious dreams. It represents our desire to explore, adapt, and thrive. While it's a monumental challenge, it's also an opportunity to push the boundaries of what's possible. Could Mars truly become a second home? The answer lies in our ingenuity, determination, and ability to work together as a species. Thank you for joining us on this journey to the future of Mars. Don't forget to like, share, and let us know in the comments. Do you think terraforming Mars is worth the effort? Until next time, keep reaching for the stars.